Dear students, now we will discuss about flag registers in 8086. As we know that flags are set of flip-flops which are used to show the status of any arithmetic or logic operation. In 8086 there are 9 different flags which are given in 16-bit flag register. So these flags can be divided in two categories. One is called conditional or status flag and another is called control flag. There are 6 different conditional flags and 3 different control flags. What are 6 different conditional flags? These are zero flag, sign flag, parity flag, carry flag, auxiliary carry flag and overflow flag. And what are 3 different control flags? These are interrupt flag, trap flag and direction flag. So one by one we will discuss about each flag. First we will see the location of these flags in the flag register. So this is the location of these flags. At the D0 bit, that is the LSB bit, carry flag is there. Then at D2 parity flag is there. At D4 auxiliary carry is there. At D6 zero flag is there. At D7 sign flag is there. D8 trap flag is there. D9 interrupt flag is there. At D10 direction flag and at D11 overflow flag is there. Now one by one we will discuss about each flag. First we will discuss about carry flag. What is carry flag? When this flag is set to 1, it means that the result of any arithmetic or logic operation exceeds 16-bit, more than just exceeds the 16-bit. Or you can say that if in any arithmetic or arithmetic operation, suppose that in addition, if carry is generated, then carry flag will be set to 1. In case of carry, we can also consider borrow if we perform subtraction operation. Okay. Next is parity flag. What is parity flag? Parity flag is used to show the number of ones or even or odd in any arithmetic or logic operation or in the result of operation. If the number of ones are even, then parity flag is set to 1, otherwise it is reset. Next is auxiliary carry flag. What is auxiliary carry flag? Auxiliary carry flag, as we have discussed in the 8085. In 8085, auxiliary carry flag is set to 1 if the carry is propagated from lower neighbor to upper neighbor, that is from D3 to D4. Here, both the cases will be considered. Auxiliary carry flag will be set to 1 if carry is propagated from D3 to D4, if the numbers are of 8 bit, or if the carry is propagated from D7 to D8 if the number is of 16 numbers are of 16 bit. If we take 16-bit numbers, then to set auxiliary carry flag, the carry propagation must be from D7 to D8, and if the numbers are of 8 bit, then the carry propagation must be from D3 to D4 bit. Next is zero flag. Zero flag is set to 1 when the result of any arithmetic or logic operation is 0. It means that if the content of this any register becomes 0, then zero flag will be set to 1. Next conditional flag is sign flag. This flag is used to show the sign of any number. If this is set to 1, then the number will be negative, otherwise the number will be positive. The other conditional or status flag is overflow flag, which is shown in the D11 position. This flag shows that if this is set to 1, then the result of arithmetic or logic operation exceeds the limit of 8086 registers. It means it cannot be stored in the register of 8086. It is very large to fit. If the number is very large, then the overflow flag will be set to 1, otherwise it will be reset. So these are the conditional flags. Now we will discuss about the control flags. There are 3 different control flags. First is direction flag, second is interrupt flag, third is trap flag. Direction flag is used in string operations, in string related operation, and when it is set to 1, then a string will be accessed from higher memory address to lower memory address, or you can say that the string will be accessed from right side to the left side. This is the this is the MSB bit of the address, and this is the lowest LSB bit of the address or data. So if a string will be accessed from higher side, right side to left side, or from higher memory address to lower memory address, then direction flag will be set to 1, and in the opposite case the direction flag will be set to 0. In the opposite case means if the string is accessed from lower memory address to higher memory address, that is from LSB to MSB, then from left side to right side, then the direction flag will be set to 0. Next flag is interrupt flag. This flag is used for maskable interrupts in 8085. When this flag is set to 1, then the maskable interrupt can be processed. Otherwise, when it is set to 0, maskable interrupt cannot be processed. Last is trap flag. Trap flag is used for non-maskable trap interrupt. When this flag is set to 1, then microprocessor operates in single step mode. In that mode, after the execution of each instruction, it checks the availability of trap interrupt. It checks the occurrence of trap interrupt. Otherwise, if it is set to 0, there is no need to check the occurrence of trap interrupt. So there, friends, we have completed all the flags in the 8086. Thank you.